Hello and welcome to Chicory's maintenance series. This week we're doing some reconfiguration of this 240 volt panel because last night we had an electrical failure. So let me explain what happened last night and what we're doing today to solve the problem. So this panel handles all of our 240 volt power. That includes our shore power, our 12 kilowatt, and our 6 kilowatt generator. This selector switch can either do the 12 kilowatt generator or the shore power, which was the original configuration of the boat. We added a 6 kilowatt generator, and what we did is this selector switch, whether I'm choosing shore power or the 12 kilowatt, comes through this breaker and then feeds the rest of the 240 volt consumers and the 120 volt consumers downstream. This breaker is for the 6 kilowatt generator. So you can see that we have isolation for both the generators and the shore power. It's a little unusual configuration, but part of this is because the way the boat was originally configured. So this also provides us with great solutions for this problem. So I'm going to push on this breaker and you'll notice that it does not stay engaged. That was the problem that we had last night. We started up the 12 kilowatt generator. I came up to flip on the power and it would not go on. Luckily, we had the 6 kilowatt, which means we shut down the 12. I just flipped this lever up, flipped this on, and we ran off the 6 kilowatt charging the batteries last night. So how I'm going to fix this is one of the things that I do as part of designing systems that I build is I build in redundancy and I build in extra capacity. And I did the same thing here. The 12 kilowatt and the 6 kilowatt are both wired with the same gauge wire, and I have breakers that can handle either one of them. What that means is these breakers are designed to protect the wiring that is downstream from it. So if anything from between this breaker and, let's say, the washer or dryer or whatever it's powering has a fault, this breaker will flip. So it's protecting wiring downstream. What I did is I wired the boat downstream from both the 12 kilowatt and the 6 kilowatt with wiring that can handle electricity for the 12 kilowatt. That allowed me to put a breaker in here that can handle the amperage for the 12 kilowatt, which is a 50 amp breaker. What that allows me to do now is I can actually use the 6 kilowatt 50 amp breaker for both the 12 and the 6 while we're here at anchor in the Bahamas. And I'm going to take this shore power part of this rotary switch. I'm going to switch this to 6 kilowatt. So basically I have the 12 kilowatt and the 6 kilowatt selected here. And then I'll use this 50 amp breaker to protect the wiring downstream, and I won't use this other breaker that's broken right now. So I'm going to start this process and I'll take you along for the ride. First thing I'm going to do is, the way I have this configured is these are just press fit in, so I can actually, you know what, I think these are screwed in. Yep, these are screwed in. So I'm going to take off these protective guards, and I have 2 screws holding in this panel. And I'm just going to unscrew and pull this out. Now the first thing I'm going to do is I'm going to grab my multimeter. Now there's obviously no way, because I'm not running any generators, there are electrical current going through this. But it's such an important safety step that you should never skip it. No matter how positive you are, there isn't electricity here, you always should check before you start fiddling around. So I'm just going to grab my multimeter and check this. I'll be back in 1 second. And I'm just checking everything. There's my generator. There's nothing there. Here is shore power. Of course, there's nothing there. And here's the feed down to the other one. and there's nothing there. So I'm safe to continue working. I need to work at both panels at the same time, so I'm going to pull this out a little bit and then pull this panel out. So I have, the first thing I'm going to do is disconnect the incoming 12 kilowatt wires from the rotary switch. Actually, it's not 12 kilowatt, it is just the power from the rotary switch. So I have that off and the red. So here are the 3 wires coming from the rotary switch. I'm going to set those aside. And so at this point, I've pretty much deactivated that top breaker that's broken. So I am going to put the washers and the nuts back on. So the bottom breaker that's here has the 6 kilowatt feeding directly into it. So I'm going to remove those now. So what I've done on the bottom breaker, I've taken off the red power lead coming from the 6 kilowatt. But remember, now I want that breaker to receive power from here. So I'm going to set the 6 kilowatt aside, and I'm going to grab the red wire that's bringing power from the rotary switch, and I'm going to wire it onto this stud for the bottom breaker. Now I'm moving on to the white. I am taking the white off. Just dropped a washer, just grabbing it. All right, so I'm moving the white wire away from the 6 kilowatt. And now I'm pulling in the white wire from the rotary switch. And then reassembling that part. Tighten that. And then the last one is the black. So then I'm taking the black from the rotary switch, which is the last one, putting that on the breaker. So the bottom breaker is now wired to the rotary switch. I'm going to put this guard that I took off back on. And then I'm going to take the 6 kilowatt cables and then feed them through this opening here for the rotary switch. So what I'm going to do now is, over here is the shore power inlet cabling. I'm going to disconnect the shore power, hook up the 6 kilowatt in its place, tape off the shore power for right now, and I'll be able to select either the 12 or the 6 with this rotary switch and use one breaker. Okay, so the generator's on right now, and these are the wires coming in from the generator, and I am seeing 243.7 amps here. This bottom section here is the 6. And if you look at the front, I don't know if you can see it, but I've got the 12 hooked to shore, and you can see that the power light is on and that it is not reverse polarity. So I have my breakers off, all of my breakers off on this panel. So I'm going to switch the rotary switch to shore power, which is turning the 12 kilowatt to power this panel. So the next thing I'm going to do is I'm going to check to see if I have incoming power over here. Trace, can you come over here? Voltage here.
243.8, 243.2.
Okay, so now I'm going to move to the other side. I should have 0 here. What I got?
0.
Okay. So now I'm going to flip on the this new breaker, or the breaker that we know is working. I can see green lights on here. So now the power is on. I'm testing the power with our, why don't you hold this for a second? So this I can put away for a minute, because this is, actually, you know what, I'll shut off the generator and do that when it's not hot. But I have 61.8 hertz right now, 242 volts. So everything's working the way it should. Once again, I have everything off, and one of the things I have off right now is the auto transformer, because I didn't want to feed anything to the 120 volt panels until I had checked this. So the project's done. You saw me testing the voltage here and the voltage here. So let me just recap what we did. This used to be my shore power and my 12 kilowatt, and those used to feed through this breaker. This breaker failed, and so I needed to use this breaker. So I disconnected the 6 kilowatt from this breaker, hooked it up to the shore power, so or I'm sorry, the generator 1. So the generator 1 right now is the 6 kilowatt, power runs into there. The 12 kilowatt runs into the shore, so I can select with this rotary switch between the 6 and the 12 kilowatt generators. And then whenever I do that selection, it goes through this breaker to turn on basically all the power downstream and to protect the wiring downstream. Right now we're charging the batteries and heating water. I'm going to start making water shortly with our water maker. So everything is working perfectly. I'm super happy with the solution. It does require, once again, that when I go into a marina, I'll have to tear every single thing apart and rewire everything. But by that time, we'll have a new breaker and I can rewire it the way it was. I think you've seen maybe in my spare parts video that we have tons and tons of spare parts. And you might be asking why we don't have a spare part for this breaker. We actually tried before we came on this trip to order one, but there was so many supply chain issues that we couldn't get it. I didn't think it was going to be critical if it did have a failure, because like I said earlier in the video, I have it set up where I can rewire it. I have redundancy built into this. And in a crazy emergency, I have 2 breakers for the shore power as they come in at the receptacle next to the pilot house, and I also have a 50 amp breaker as it comes out of the isolation transformer. So in a critical situation, if let's say both of these died, there are other 50 amp breakers on the boat that I could scavenge and make it work. It wouldn't be pretty, but it wouldn't end our trip. Right now we're not planning on going back to the United States for about another 6 weeks. So doing these kind of things and making sure that you can fix things with the parts that you have on the boat, even if you don't have spare parts, is an important part of designing your systems. And so you can keep that in mind when you're making changes or repairs to your boat. So that ends this video. I appreciate you liking, commenting, subscribing, and of course viewing. Until next week, bye.